Hello, everyone. Welcome to Build an MCP Server with Java. So my name is Sergio Del Amo. I am from Guadalajara, which is a small city close to Madrid in Spain. I work in Oracle Labs. I am a Micronaut committer and have been involved with Micronaut framework since its beginning. I was previously also involved in open source in another JVM framework called Grails. My website is sergiodelamo.com, so if you have any question, I will be in the conference until tomorrow, and if not, you can find my contact information there. I'm gonna do mostly demos today, and the demos involve LLMs, internet connection, and many things. So some of them may go wrong, but the demos are in this public GitHub repository. So if you want to check them out, they should be here as well. I'm gonna be showing also. So if I can show the URL later also. I'm gonna be showing also a more fully fledged MCP server, which is running live in the domain mycon.fun/MCP, and it's also in a GitHub repository in the Mycon project's GitHub organization in mycon.fun. I'm gonna be showing you the code and gonna be discussing the several things that you may encounter while building an MCP server with Java. How many of you have built an MCP server already? How many of you are Spring developers? Quarkus developers? Micro developers? You rock. So, as you will see, MCP server is programming language agnostic, and as you can imagine, being programming language agnostic is also Java framework agnostic. So hopefully, if you have never heard of Micronaut, or you are going to take a lot of takeaways, because at the end of the day, it's a client server architecture with JSON responses. So what you're going to learn today is going to apply no matter the framework or programming language you're going to use. But this session today is to learn how to build this using Java. They recommend me to do a 30-minute break. So instead of doing 3 hours in a row, we're going to do a part one, and then we're going to take a break, grab a coffee, and then continue. So MCP. MCP stands for Model Context Protocol, that you probably are aware of. And it's an open standard, although they are not going through the typical standard organizations for connecting AI applications. In my opinion, it really makes LLM interesting because it allows for us as programmer to code in a LLM agnostic way, so you don't have to create APIs especially for ChatGPT or APIs especially for Claude. You can create APIs that any LLM can consume. And for example, in Oracle, we use C-Line. C-Line supports MCP servers. Your organization may allow you to use Claude code or GitHub Copilot, and MCP server is kind of a way of being technology agnostic so that you can connect any program. The website, which we are going to be visiting today a lot, is modelcontextprotocol.io. And if you go to modelcontextprotocol.io, you're going to see an image such as this one. Again, the idea is that you can have a standardized protocol that allows LLM to call servers, and typically they will get new capabilities, they will get resources to augment the context, or they will get prompts, which is something that typically when you talk about MCP servers, most of the time we talk about tools. But hopefully today I will give you a couple of examples of using prompts to essentially improve your day-to-day. And this is kind of the definition that we have been talking already. There are 3 parts that we're going to be discussing today. Again, the MCP is important because it eliminates the need to code against an API. I remember several years ago I was in a conference and it was a session dedicated just to code against the OpenAI API. And I am glad that as an industry we figured it out to essentially have a way to be able to write programs that they are not coupled just to OpenAI and to Claude, but basically can be technology agnostic. The benefits of MCP, freshness. Right now, if you go to ChatGPT or you go to Claude Desktop, they do a little trick, which is you will see that there is also always like a toggle to essentially do. So if I go here to Claude, for example, you will see there is always like a toggle for web search, which you can see here. So the models, they do the trick that they are essentially all these applications, they are not just LLM models, they are LLM models plus web search. It's kind of a mix of a model plus a search engine. And if they are going to augment the results coming from the model with the results coming from web search. But what you can do also is, if you don't have this web search capability, you can basically give up-to-date information to the model's training data. You will see that, for example, in Micronaut, which is this MCP server that I'm going to show you later today, I am creating resources for all the Micronaut documentation, for the Micronaut documentation and the configuration reference. So if you want to do a query, you can say, okay, this is the latest Micronaut security configuration reference documentation. Give me the settings to, I don't know, to change the default HTTP status code to be 404 for page not found instead for 401. And the model is going to basically augment its context with the resources that the MCP server is going to provide. Another really cool thing, and this is probably the thing that gets most people excited about, is automation. Thanks to MCP servers, LLM models can do things. So you can do like, in all the examples that you are going to see, is like create an event in my calendar, or send an email for me, or control the browser. I saw the other day, for example, that Chrome released an MCP server for the browser, so you can basically control the browser and connect to the developer tools to see, to essentially get information to the model about how your application is behaving in the browser. So I guess imagination is the limit to how we can extend thanks to MCP servers, and the extension typically is referred to as tools. So there are tools to basically allow the LLMs to do more things thanks to MCP servers. Another side benefits that you can get is reduced hallucinations. Again, you can basically give like more up-to-date information to try to keep LLMs grounded. Another thing is about privacy. One great feature of MCP servers is that they allow you to connect to data. So this is, I'm going to show you also today, for example, I have a web application for chess games. And I have like a database, a really simple CRUD application where I am saving chess games in a database, and I can connect Claude with authentication and tell me like, have I played against this player, and what did I play? Did I play this opening? What should I play instead? And they allow you to connect to your data. For example, there are MCP servers or databases that allow you to connect directly to Postgres, for example. So they allow you to essentially augment all these LLMs with private data from yourself or from your company. And they essentially combining this access to private data with tools, they allow you to create really cool automations. As I was saying earlier, the idea of a model context protocol is a client-server architecture. There are typically three actors involved. There are MCP clients, MCP hosts, and MCP servers. Sometimes when you access like Claude or GitHub Copilot, the host and the clients are a bit mixed, but essentially the host is kind of the LLM, and aside the host is running an MCP client, which will connect to the MCP server, and it will basically have like a client-server architecture. So essentially, the client is the one that will connect to the MCP server, which is the one that is going to provide this context, this tool, these capabilities that we are going to see today, and they will make sense. And then we have the host, which is typically the LLM. Two layers for model context protocol, the transport layer and the data layer. You can think that the transport layer is above the data layer. The data layer defines the communication. In the specification, they define the use of JSON RPC messages to communicate. We're going to see the MCP Inspector, where they are not showing you the JSON RPC envelope, which is a pretty thin envelope. But essentially, that's the way it works: is JSON RPC messages go to the server, and JSON RPC messages come back to the server. And the transport layer is above, and it was a clever decision because it allows different kinds of transports. In the latest specification and MCP server specifications, they are changing in a quite heavy pace. The latest specification, there are two transports. There is the standard input, standard output transport. You will use this when you are running the MCP server in the same machine. So we will see today that you can generate, for example, with Java, you can generate a fat jar or a native executable with GraalVM, or you can invoke your fat jar using JBank, and you can communicate right into a standard input and a standard output. As you can imagine, this is fast because you don't have to do any HTTP request or anything like that. So this is kind of for MCP servers that you can run in your local machines. There are MCP servers, for example, to create folders in your computer, to read files, anything that you can do in a machine, right? There is a question of the security boundaries because this MCP server is going to be running with the same access as the user in your computer. So you have to be really careful about which MCP servers you trust that you are running in your computer. But even for writing your own MCP servers, you will see that it's pretty simple to do with Java. And we will write one today without any framework, and then I will show you how to write them with frameworks. The other transport that is defined in the latest specification, which is from June, is the streamable HTTP transport. It's essentially, they didn't call it HTTP transport, and they put the prefix streamable because there is a post request against an endpoint sending JSON RPC messages and getting a response, and they allow the server to optionally create a server-side event connection to the client to essentially have the capability for the server to send messages to the client. And these messages typically will be things such as notifications. So imagine an MCP server that does a long process. You may want to send notifications about how the action is being performed, if it's progressing, things like that. But the server-side event part is optional, and today you will see that I'm not going to be showing that today, but that's certainly there. It's in my opinion, it's going to be more useful when you have like kind of more machine-to-machine communication more than MCP servers like serving an end user. But yeah, this is the latest specification, and my gut feeling is that we are going into where most MCP servers will be completely stateless, and there will be a few scenarios where these stateful capabilities provided by server-side events come useful. but the majority of the MCP servers will be fully stateless. As I was telling you before, the data layer, JSON RPC to messages. You have never heard about JSON RPC, don't worry. I hadn't heard about JSON RPC until a couple of months ago. And it's a pretty simple specification that defines this JSON structure, which the protocol reuses. MCP server key components. I'm just finishing the slides that I wanted to show you. And we're going to go to demos. Resources. Static or dynamic is there because you can define a list of static models. That means that they are listed in the resources and the user can select them, for example. And by dynamic is the protocol define what they call resource templates, where you can have inputs, and depending on the input, you can return a resource. Prompts, they define predefined workflows. I'm going to show you how I'm using prompts to essentially improve my day-to-day work. The idea is if you have a prompt that you want to write, I don't know, if you are using a code assistant and you want to say, I want for you to test this class, but to test this class, I want you to test it in this particular manner. For example, in Micronaut, we have an abstraction on top of Jackson, and you can use Jackson, or you can use something that we call Micronaut serialization. And when I test serialization, I want to test how an object is serialized into JSON. I don't want to use object mapper. I want to use another API called JSON mapper. And the LLM typically will want to use object mapper. And I can basically write a prompt and tell, I want you to test serialization, but please use this API, JSON mapper. And if I don't want to save this prompt in a text file in my computer, I can have an MCP server which essentially provides me these prompts. And I will show you today an example of that. Or for example, if you are connecting to an MCP server for your accounting and you want to have a prompt that essentially takes calculate the balance sheet and the profit I've lost, given this accounting information, you can essentially create that prompt. Tools is the last part, so prompts, resources, and tools. They're often referred to as MCP primitives. And tool is basically to do things. Tools, they don't have to be destructive, so they don't have to be write tools. They can be also get tools. And you will see that some providers, they want you to make a distinction so they can show in the UI whether a tool invocation causes side effects, and I will show you how to change that. One funny thing is that you don't call tools directly, so the LLM is the one that is going to call a tool. So you're going to say, my server offers you these tools, and when you write to the LLM, it's up to the LLM to decide if it invokes the tool or not. You don't have any control. So the LLM will say, I see that I have this tool available, and maybe if I use this tool, I am able to fulfill what the user wants, and they will call the tool. So you don't invoke the tool. The LLM basically decides whether you call the tool or not. Tool safety. What basically they tell you in the specification is that you should list the tools and you should allow users to essentially disable tools. So for example, in Claude, what they have done is, if I go to an MCP server, you see that they see the list of tools, and I can toggle them. I can even have a project where I have certain tools available, and I have another project where I have certain tools disabled. And when we invoke the tool, you will see that one of the things that they tell you in terms of security is that you see the input and you see the output of the tool. And they ask the user whether they want to run the tool or not. I told you before that the LLM will call the tool, but the LLM will call the tool and they will show you a UI interaction where they say you, do you approve for me to call this tool? And you are going to have to say yes. You can say yes, you can say yes for this session and things like that. So this is the approval dialogues that I was talking to you about. There are some toggles that you can say pre-approved tools to be safe. So for example, all the Micronaut fan MCP server that I'm going to show you, they are basically it's kind of a documentation server. They are not going to do anything harmful. So I could pre-approve those. They tell you like to show activity logs, so that you'll see tools execution, as I told you. We're going to see this in the demos. MCP Inspector. So I think with this, we are ready to show you the demos. So let me see. MCP Inspector is a tool that you have to use. Is, in my opinion, indispensable to work. Is if you go to model-context-protocol.io, you are going to find here in Inspector, should be, I think I have internet connection, but well, don't worry. So the link is broken probably there, but in order to run the MCP Inspector, not a good starting point, I'm going to go here and I'm going to do, I have a shortcut here, MCP Inspector. Essentially, this is the command. It's an npx command. This is going to run a local server, and this is the UI of the MCP Inspector. And you will see that you have here like different transport types. They are still listing the SSC, which is for the previous version to the version from June of the specification. And we're going to be using this all the time. I discovered yesterday that you can use Postman as well. I will show you that later today. But MCP Inspector, if you want to write an MCP server, an absolute must. I'm going to show you also how to write tests, but the MCP Inspector in kind of playing around is really, really helpful. So let's try to create our first MCP server with Java. I'm going to go in IntelliJ. You don't have to use IntelliJ, it's just this is my IDE of choice and I am more comfortable. I'm going to select here the archetype Java project. I have here a folder which should be empty. Not empty, but let's empty the folder. I'm going to create a project name stdio disk space. So we are going to create MCP server using the standard input, standard output transport that is going to tell me the disk space in my computer. Okay? Which, as you can see, is something that the model will not have, right? And we are going to basically enhance the model. So I'm going to say Java SDK. I'm going to select Gradle as the build tool. I know many teams use Maven. You could use Maven with all the demos. I'm not going to do anything Gradle specific. Just I'm more comfortable with Gradle. If someone needs any clarification about any Gradle concept, please let me know. I'm going to go with Gradle, and this is going to create a project. I'm going to try to go to presentation mode so that you can see something. So the first thing that we are going to do is, if I go to GitHub, so if you go to the repo of this deep dive, you're going to see in the README file some links, which hopefully are useful. One of the links is the MCP Java SDK repository, which is contributed by the Spring people. I have started contributing. I have a couple of PRs that I will talk to you about in a second. And it has a lot of activity. So it's stewarded by the Spring team, but as you see, there are a lot of contributors, a lot of PRs, a lot of issues. So seems there is a lot of Java community interested in MCP. So I'm going to be adding a dependency, and I have here, I use so much the Maven Central search that in Safari you can save kind of it creates kind of a desktop application for a website. So this is essentially, I'm going to search here for MCP, and let me search for MCP bomb. So the group ID that we are looking for is this one. So I'm going to go here to build.gradle.kts. Let me see if I open it here. So we are going to add the dependency to the MCP. As you can imagine, we need some classes from the MCP Java SDK, so we need the dependency. So I'm going to go here, I'm going to go implementation. This is equivalent in Maven to the compile scope. I'm gonna go MCP, just MCP, and the version number. I'm gonna take the latest, which is 0.14.1. They published a bill of materials, but I only have one. I only need one dependency, so I don't need a bomb. Okay. I have a typo. So MCP is just an umbrella dependency. It contains two dependencies. It contains the MCP core and the MCP JSON Jackson 2, basically. We contributed to the MCP Java SDK a pull request to decouple the SDK from Jackson to allow consumers of the API such as Micronaut to provide other serialization. So in Micronaut you can use Jackson or you can use Micronaut serialization, and I will show you the API that basically makes this agnostic. So in Micronaut, for example, we depend on MCP core, but for this demo I'm gonna be depending directly on MCP, which is MCP core plus the Jackson part. Okay, so first thing that we need is the dependency. We have it. We're going to generate a fat jar. So if we were to use Gradle, this may have been a little bit faster because Maven is basically immediately allows you to do Maven package and generate a jar. So in Gradle, I'm going to add a couple of plugins. I'm going to add the application plugin, which is really simple plugin. I'm going to configure it with 2 pieces. I'm going to go here. I'm going to go example application. I'm going to click the elephant with the refresh button here. I'm going to create a package. Example. I'm going to go application. Was already helping me. So we have a main class. And the other thing that I'm going to add is I'm going to add the shadow jar Gradle plugin, which essentially what you will do is when I run build, this is going to generate a fat jar that we are going to invoke, right? So as you see, this /all is the fat jar that we are going to do Java minus jar. Make sense so far? Perfect. So now that we have the non-interesting part, let's do the interesting part. So we're going to call MCP JSON mapper. This is the extension that I was talking to you about abstracting the serialization. So this is using SPI. So you could override, basically. If you go here, you will see that this is essentially, you don't have to, but this is essentially using, you provide via SPI a supplier, you can essentially override it. So this is what we are doing downstream. So this is essentially the JSON mapper. Think of it as the object mapper that you probably have used a million times when using Jackson. Then we have another class. We want to use the STDO transport, right? So there is a class called MCP STDO or STDO. Let me check if I have the dependency. I do. STDO server transport provider. And this takes in the constructor, the JSON mapper. And as you can imagine, the transport provider provides the transport. So it basically gets the transport. So I'm going to call this transport or transport. Let's call it transport, yes. Now, the Java SDK has 4 servers, which is a bit confusing, I know. It has the sync server, the async server, the stateless sync server, and the stateless async server. the way I'm thinking about those is typically you will use the sync server for STDO and the stateless for streamable HTTP or just the stateless HTTP if you want. So I'm going to go MCP server sync. So I think the distinction between sync and async is because Spring has this distinction between WebMVC and Flux. So I think that's basically the string API influencing the MCP SDK. So this is, even if this is called a specification, this is kind of a builder API. So I can essentially, the idea is that at the end of this thing, we're going to do .build, right? Okay. So then another thing that typically you will do is you will set up the server information. This is going to be provided in the, you will see that there is kind of a handshake. There is like an initialization and the server info is going to tell the server name, which is going to be useful. I typically like to use, I think this is an object or string. I think string is the name and the version. Yeah. So what I'm going to do, I like to put this in lowercase. I think if you don't provide it, they have a default, which is MCP Server and 110. And then capabilities. I'm going to be a good citizen here. I'm going to do capabilities. Server capabilities, they have a builder API. I'm going to say .build. And I think, if I am not remembering anything, which probably I am, we should be good to go. We should have like an MCP server. I'm going to just generate the fat jar. And I'm going to go here to downloads. I made the font bigger, so you don't be blind. I put the demos here. As you see, I do a lot of demos. And this is going to be here. I'm going to take this. So I remember the MCP Inspector that we just talked about in a second. So let me just close other tabs. So as you see, stdio Java, so you have the command. So if you were using npx or something like that, you would put here a different command. For us, it's going to be Java -jar or JBang if you wanted to use JBang, which is perfectly great to do this as well. And I'm going to select also this. Finger crossed. So we connected to the MCP server. Let me show you the interesting part. This is a really bare bones MCP server. We don't have anything, so don't be too excited about this. But essentially, the client first did a... I'm going to open it here in IntelliJ IDEA so that we can do the font like a million times bigger. So you are able to see it fine, right? So essentially, they sent an initialize, and what our server response is... which I don't like the response, but they're essentially responding the capabilities of the server. So there's kind of a capabilities negotiation, and don't trust that the clients will respect the capability negotiation. I was surprised by this. I will talk you more about it, but I think, in my opinion, the Java SDK shouldn't respond that we support logging when we are not saying anything. So I think it should only support logging when you say login, but this is the way it is as of today. So we are essentially advertising that our server supports logging, and this is the server info. This is kind of us telling the client, my MCP server, this is my name and this is my version, right? Apart from tools, resources, and prompts, there is kind of a ping that we should be able to hit. So if I call ping, I should get a 200 OK with an empty response, right? So an MCP server should respond to the ping server, and our server already does this. So apart from this, you see that the server is, because we told the server that we support logging, they send us a notification, a request setting the log level, and we are here like sending the logs automatically will be sent because we don't have any SLA4j implementation. They are being sent to the client. So First, Java MCP Server demo successful. We created a server, we were able to connect, and we were able to ping the server. But as you can imagine, not really interesting. Let's try to add a tool. So I'm gonna come here, and this thing has here tools, which takes it takes basically an array of specifications. So I'm gonna say tool spec. This is what we are gonna build in a moment. And the sync tool specification, if I am not mistaken, takes also a builder API. And it takes also a tool, which is also a builder API. And we're gonna give here the name of the tool. So I'm gonna say name, disk space. I'm gonna say title, disk space. I'm gonna say description, reports, the disk space in the user's computer. And an important thing that you have to do when you define a tool is you define the input schema. And this is really important because what I was telling you before is that you are not going to call the tool. The LLM is going to call the tool. And because of that, the LLM needs to know how to call the tool. So you have to provide the instructions to the LLM how to invoke the tool. And the way you provide the instruction is by supplying a JSON schema of the tool input, and you can supply a JSON schema of the tool output. I'm going to show you later how to do this in a more elegant way. In Micronaut, we have a model that generates JSON schema at compilation time, but for this framework-less demo, we are going to use the JSON schema class that the MCP SDK provides, and we're going to say type. So this is essentially a class a Java class that kind of mimics the JSON schema structure, so that we can serialize and create a JSON schema JSON document that we can supply the tool. It will make sense in a second. So the properties of this, so this tool doesn't have any input. So I'm going to tell essentially collection empty map, collections empty list, null, null. I think it's 2 or maybe 3 parameters. So this is the, I'm going to call this input schema just to have. Okay. And let's assign this to a variable called tool. And so this is kind of the tool definition, right? We have to define what happens when the LLM invokes a tool. So this is typically a handler, which is in the SDK is always like a by function in Java, which thanks to IntelliJ, I'm able to write this nicer. So I'm gonna, just to keep it simple, I created probably not the correct way of doing this in Java, but bear with me for a second. So I created a dummy utils class in Java that essentially returns the free space. I don't know if this is the correct way of doing this in Java, but this is the way I did it. So a util class, nothing fancy, but it will return the space in my computer. And now in my handler, I can invoke it. And the by function, it has 2 parameters and the result, which is called tool result. So called tool result takes a list of content, and then I think is whether it's an error, a structured content, which I will explain you later, and meta. So I'm gonna do false, null, null. And for the first parameter, I'm gonna do list of new text content. And let me resolve the import here. And now we're gonna call the this util class. And I'm gonna say from a Java SDK, from the MCP Java SDK. And I am missing a parenthesis apparently. And I don't know what else I'm missing. Yes, I think I'm missing a parenthesis here, not in the other place. Let me just extract a variable so that we make sense of this mess. So this is going to be a list of content, I believe. Contents. So this is just to recap. So we define the tool. A tool specification consists of kind of the tool definition, which the tool definition is the name, the title, the input schema, the output schema, which is optional and we will supply later, and what will happen when we invoke the tool. That's the tool handler, and then we supply the tool spec. So let's try to build. And to build, we have to compile first. So let's try to build. And now we're going to try to reconnect. It's not working. Because in capabilities, I think we have to tell that we support tools. I'm going to say false. So the specification declares that an MCP server can send a message to the client informing the client that the tools list have changed, so that immediately after receiving that, do you have any question? The capabilities is there is a handshake in the initialize method, and the MCP server basically tells the capability that it has, and also the client. So a tool is one of the capabilities that an MCP server can have, but an MCP server, as you will see, it can have tools, it can have prompts, and it can have resources. So it's just one of the capabilities if you want to think about it. So let's try again. So the reason it didn't work is when we sent this, there was no capabilities, and the MCP Inspector, if you don't advertise tool capabilities, basically will disable this button right here. So let me just recreate the fat jar, restart the server, and now we can see the list of tools. And I think it's telling me basically, you don't see because it's tiny, but the error message is telling me that there is an error in my input schema. Object, it seems correct to me. So it seems there is a bug here. Here it should be object, not type. So let me try again. List of tools. So the client sent this message, list of tools. And let me show you the response from the server. So the response from our server is essentially the tool that we created, right? And the input schema. This is really important because this tool doesn't have any arguments, right? But the interesting tools is when you supply an argument and you need to pass like a name or something like that, right? So in the input schema, the LLM will discover how to invoke the tool. So now I can basically run the tool here directly from the MCP Inspector. This will do a tools call request. And as you see, the demo work. And we got this answer back from the server, right? So apparently I have 122 gigs free of space in my computer, and this is from the MCP Java SDK. So this is what I wanted to show you in terms of MCP STDO Java SDK. I'm going to show you how to do this demo with Quarkus, with Spring, and with Micronaut, and we're going to see that. Go ahead. Yeah. Each tool, the name of the tool is the unique identifier. So when let me show you the call invocation. So when the MCP client calls us, they essentially supply the name of the tool that they want to call. So you essentially route, the handler is associated to the name of the tool. So it's a kind of a map of a tool name to handler. Yeah? More questions? No, this is not an this is not an MCP server. This is not an HTTP server. This is an standard input, standard output server. So if you see in the MCP Inspector, we are essentially connecting. We are basically running the jar, and the jar is writing to input and reading from output. So, and the MCP client as well. So this is not yet. We will do this with HTTP, but this is still just a standard input, standard output. Let me do this with Quarkus. Let's start with Quarkus. Or with, yeah, let's start with Quarkus. So I'm going to do Quarkus. Let's do the same structure, stdio, Quarkus, and this or disk space Quarkus. So Quarkus, not an expert in MCP Quarkus, but my feeling is they are probably the most complete in terms of transport support. They support the whole SSE and also streamable HTTP with SSE as well. They are not using the Java SDK, as far as I'm aware. They have a pretty similar model to what you will find in Spring and Micronaut, where you can define tools via notations or programmatically. So in order to, so let me create a, I think I didn't select Quarkus, right? I just selected, yeah, let me just delete this application that I just created and let's create a new one. So Quarkus has an integration in IntelliJ IDEA, so I could go to the Quarkus web and click, I think if I go here, it's the same idea that if you go here to Quarkus.io and you create here start coding, I believe. So I'm going to use the integration that they have directly in IntelliJ IDEA just to be faster. I'm going to do stdio disk space Quarkus. I'm going to go Gradle Kotlin. 21 is fine. Let's create an app. Okay, I think I did a mistake. We don't need the rest part because, as the colleague just said, we are not building an HTTP server, so I don't think we need that. Go to the Quarkus documentation. They tell us here in the supported transports, it tells us to transport stdio streamable HTTP. It tells to use stdio, use this one. So let's follow what the Quarkus people tell us. So we are going to add the stdio. I'm going to go and I'm going to do, I'm going to create the disk utils class again. And I have my shortcut. And the package is now org.example. Okay. And as you see in the Quarkus documentation, you can use essentially a bin, but you don't need to annotate to singleton because they will annotate it automatically for you, they tell. So I'm going to say my tools. And you don't have to specify that singleton. I'm not going to need to do dependency injection because we are not using any collaborator, but in a real scenario where things get more interesting, you will use a collaborator to be invoked in the handler. For description and things like that, let's use the same thing that we use in the other one. So let me just open the project that we just work with. So I'm going to use this. So Quarkus, they will use the name of the method as the tool name. If you want to use a different method name, you can also use the name member here. But if you don't specify it, it will default to the method name, which for me is fine enough. For title, I'm going to go with disk space. For description, let's use the same description. As you see, the Quarkus example in the documentation was using an argument for the tool. We don't have any argument, so you don't need to use this. And for the tool response, we're going to use our util class, disk utils, free disk space. Okay, and let's do here from Quarkus. From Quarkus MCP Server, that looks fine to me. We need to do a couple of things more. So if you remember in the demo here, when we were using the Java SDK directly, we were supplying the server info, right? So in Quarkus, you will do this with a configuration property. I have a shortcut here to remember. So you will use info name and disk space and the version, sorry. Another thing important is we are gonna pass, so I'm gonna put a configuration in Quarkus so that we are able to generate an Uber jar. So I think I have a shortcut here like this. And one gotcha that you are gonna find when using STDO and any of the common Java frameworks, Quarkus, Micronaut, or Spring, is that all the frameworks typically they come with login, and we don't want to log to STDO, right? Because if we log to STDO, we're gonna mess the communication with the MCP client, right? So we don't have to log to STDO. Typically, you will log to error, or you will log to a file. So I'm gonna configure the Quarkus application to log to a file. And I am apparently using a deprecated property, but forgive me. This would be, I think, fine enough. And I think the command to generate a fat jar in Quarkus is Quarkus build, hopefully. And I deleted the rest, but it generated some sample code, which I'm going to delete happily. And I'm going to delete the test as well. This is going to generate a fat jar, and I'm going to go to the MCP Inspector. We're going to disconnect, and I'm going to get the path to the application. I'm going to use the terminal, otherwise I will make a mistake. So I'm going to go to the Quarkus folder now. Funny name. So I think they put the fat jar here when you run Quarkus build. So I'm going to take this plus this. And fingers crossed. Let me clear here. Let me clear here. Clear. Let me restart. I think we connected successfully, but just to reconnecting. Let me just close the. I'm gonna close the. Let me just run the jar to see if. Okay, it seems to be fine. Trying to run the inspector again. Yes, copy this again. I think it should be fine, right? There you go. So initialize, let's see what Quarkus initialized. So they initialized the tools, and they initialized what we passed, essentially. They also added the title for the MCP server using the name that we supplied, I believe. And if we go to list tools, we should be able to invoke the tool. And as you see, coming from the Quarkus MCP server. So as you see, Quarkus provide quite a nice developer experience using annotations, but they also allow you to define MCP primitives. So they allow you to define tools also using programmatically, basically. You can register them programmatically, which there are certain scenarios where you will want to do that. Let's try to do the demo in Spring. Any questions so far? Good, good, good. Let's go. Let's do Spring Boot, I guess. So I'm gonna go stdio disk space Spring Boot. Gonna go with Gradle coding again. Let's go with Java.21. Let's put a package which is less ugly. So in the repo that I shared with you earlier today, you will find a link to the, not to this one, to this one, to the MCP Server Spring Boot Starter, where they tell you like the different dependencies that you want to use for different transports. This is the dependency that we are going to be using. So it's the Spring AI Starter MCP Server dependency. I don't know if I had to. If this doesn't work, we will try to create adding it directly and selecting the feature. So the dependency is similar to what we did in Quarkus. Next, I'm gonna add the what? I'm gonna show the mile-by-one milestone with the HTTP streamable later today. The STDO should work with this one. Fine. So I'm gonna add the disk utils as well. Hopefully. The experience that you typically will get in using like MCP Server with Spring is they allow you to, Quarkus also can allow you to do a similar thing where you can have like LangChain for your tools and you can expose those as MCP Server tools. I'm gonna create here my tool similar to what we did with Quarkus, but I think I have it here. Spring 3 probably. Spring 2. I think I need the Spring AI dependency, right? Let me just go to start, spring.io, MCP server. Let me see what I missed in my file. Okay, so you create a Spring AI service, you define the tool. We're going to use the same metadata that we used in the other one. Let me just copy from Quarkus, which is probably faster because it's kind of an annotation as well. So I think they support also this name instead of title. So let's use name. And then what we have to do, disk space, this is what is complaining. Then what we have to do is here in application, we have to inject here my tools. and return this list of tool callbacks. There you go. So dependency, we register the tools as an Spring AI service, and then we return a bin of list tool callbacks. Then similar to Quarkus, we have to supply the name of the server and the version. We have to tell this is not a web application. I don't think if this is necessary because I don't have the web application dependency, but let's set it up nonetheless. And same as with Spring and with Quarkus or with Micronaut, you will see that you don't have to log to standard input, standard output. So I'm gonna do Spring 6, I guess. So I'm gonna toggle the Spring banner off, and I'm gonna set the console pattern to nothing, which I guess it will not log anything. And with this in place, I think I have all the ingredients, hopefully, to build a fat jar with our MCP server written with Spring using the stdio transport, and the server should be under build libs. And I think it's the one without plain. Gesundheit. So I'm gonna go to stdio, this case Spring Boot, build libs. I'm gonna here, and here. Okay. Okay. It looks okay to me. Let me try to close and restart the MCP Inspector. There you go, there you go. There you go. The Mogots are with me today. So Spring does something which I think, I don't know, maybe they can tell us why they did this way. So what I discovered is even if in the initialization phase you tell that you don't support tools or prompts, what I discovered is that when you go to production and you deploy, the MCP clients will ignore the initialization phase, and they will call the prompts list and the tools list. Even if you are telling that you don't support that, they will call you. So what was happening to me is that I was deploying, I was getting a 500. It was crashing the server because they were basically ignoring this server capabilities protocol. So Spring by default is returning that they have resources, or they have resource templates, even if I don't have any. I don't know if this is basically when you invoke it to basically they will return like an empty list, and at least they are prepared to don't crash. In Quarkus and in Micronaut, you will see that if you don't have any tools, the tools will not be advertised. What we did in Micronaut is that even if your tools are not advertised and they call tools list, we will not crash, we will return an empty response. But this is I guess a design decision to protect themselves. You can turn it off. So there are settings to essentially say that you don't support in the initialization phase. So you can say like, so you can essentially toggle that if you don't want that. So that's a little difference that you will see between the Quarkus and the Spring MCP server. In terms of invoking the tool, it will be the same idea. You can run the tool, and there you go. I forgot an empty space, but as you see, pretty simple to define an MCP server using stdio transport with Spring. you can essentially expose the Spring AI tools as MCP Server tools as well. Any questions? So let me try to do the Micronaut demo before the break, and let's do that. So I'm gonna go with a new project, I guess. I'm gonna go with Micronaut. I'm gonna go with disk space, studio disk space Micronaut. Create. I'm gonna go to docs.micronaut.io. I'm gonna go with Micronaut MCP. I'm gonna take the MCP dependency. So this is not gonna be an HTTP server, so I can remove that. I'm gonna go here. So in Micronaut, let me just remove the AOT plugin. We don't need it for this. Just so that I think it's smaller to see. Micronaut Gradle plugin, when you specify here runtime netted, will add the HTTP server netted dependency. Maven, if you generated a Maven application, you will see the Micronaut HTTP server netted dependency explicitly. This is not an HTTP server dependency, so I'm going to just remove this. So we added the dependency to the MCP Micronaut MCP server Java SDK. We remove the dependency. I'm gonna go now to application.properties. I'm gonna say Micronaut MCP. Micronaut, what's the configuration name? Let me check. This thing. I think we call disk space. For the version, I'm gonna say 001. The other thing that we have to tell is the transport. So the transport is going to be stdio. And for logback and for login, I'm going to go to log error, to system error instead of system output, which is going to be a trick that will do enough. And now we have to create the tools. So I'm going to do my tools, and I'm going to actually open the Quarkus one, be lazy, and I'm going to copy this, and I'm going to, it's a little bit nicer in Micronaut in my opinion, but pretty similar. So in Quarkus you don't have to specify a singleton, in Micronaut you do. Let me see why it's not getting autocomplete. 1 second, exit presentation mode. Okay, I'm not getting autocomplete because I'm not specifying the dependency. So Micronaut MCP will be part of Micronaut for 10.0 release, which is going imminent, but we have not released it yet. So that's why I was not getting auto-completion in the configuration. So in Micronaut, for a tool that answers just a string, you can return a string. I don't know, maybe in Quarkus this is possible as well. So I'm going to go here. I'm going to say disk utils. Let me enter presentation mode so that you don't get blind. So I'm going to create the disk util class that we created in all the MCP servers. Let me just Java class disk utils. There you go. And here I'm going to say, so the name of the tool will be the method name, same convention as in Quarkus. I'm going to go from Micronaut. And that should be it. I'm going to package as a fat jar. And we are going to do the terminal dance to get the path to the fat jar. So this is going to be this. Disconnect. There you go. So let me just clear and reconnect so that you see the history. Okay, now I have to stop the MCP Inspector. Okay. So using the initialized, Micronaut will return the only support tools. So that's why it's highlighted there. And we can see the list of tools. And I can invoke it, get a response from Micronaut. As you see, pretty similar to do an STDO MCP server either with the pure Java SDK, no extra dependencies needed. If you use a framework such as Quarkus, Spring, or Micronaut, pretty similar between them. The biggest thing that you have to pay attention is when using STDO, you don't have to log to standard input, standard output, so be careful about that. There are workarounds, as I showed you, for all the frameworks to essentially either log to system error, or log to a file, or disable the console pattern to avoid that. And I have a lot of things to cover, so if you are okay, instead of doing a 30 minutes break, let's do 20 minutes break, and let's come back at 11 and go from there. Thank you. Hello, everyone. Thanks for being back with me today. Let's show more interesting things. So I want to show you. So we packaged the MCP server written with Java as a fat jar. Another thing that I want to show you is how to package as a native executable. So using GraalVM. A colleague of mine is doing a GraalVM deep dive after lunch. I believe it's at 1:30. Alina, so check her out. I'm just gonna show you. I have another project which I also included in the deck, which I will export as a PDF and upload to the RIP after the talk. If you have checked the Model Context Protocol website, or you will check it, you will find that if you go to build an MCP server, you will see an MCP server weather demo API, and this is the same demo but written with Micronaut. I'm not going to go into whole detail because I want to cover a lot of things, but essentially this is again an STDO server. It does more interesting things in the sense that when you call the tool, it invokes an HTTP API to get weather information. So the US government has in API weather.gov, they have kind of a REST API to get weather alerts from the US. And these tools will call, so the idea here is that an MCP server, an LLM, without a web search capability will not be able to tell you whether there is a weather alert today, right? So this is kind of a way of extending. So I wanted to show you a couple of things that Micronaut makes quite interesting. Get alert input. It basically, you see that instead of, so in the previous tool that I showed you, we didn't have any input argument. Here we have, and I am using a module called Micronaut JSON schema, which allows you the generation at compilation type of the JSON schema of an object. And the only thing that you have to do is, so let me clean this. And you see here that this class is annotated with a JSON schema. And you see that I have some Java documentation, right? If I now go here and I do compile Java, so one of the kind of the mantras of Micronaut is do more at compilation time. So if you go here to build classes meta-inf schema, you will have a JSON schema of your class. And this is where we connect all the dots. And this capability of Micronaut plays greatly with MCP Server. So if I go here like format JSON. So this is the, hopefully the font is not small enough. I cannot make it bigger. This is the JSON schema of my Java record, right? And this will basically be used automatically in the tool as the input schema. And if you define an output schema that I will show you later, the output schema will be used as well, right? So you as a developer, you don't have to do anything. You just use a Java record, you annotate it with a JSON schema, and here we go. That's going to be used for the MCP tool input schema, and if you use it in the return type, it will be used for the output schema. What I wanted to show you is if I came here and I did a native compile, so the Micronaut Gradle plugin brings transitively the Gradle build tools native plugin, also in Maven, the same idea. And it's really one command to generate a native executable with GraalVM. But instead of generating here in my computer, what I'm going to do it is I'm going to do a release. So I am using the GitHub GraalVM actions to generate the native image here in CI. So let me make it big so that you see it. So when I do a release, I'm going to generate a native executable for each operating system. So I'm going to generate for macOS, for Windows. I'm going to be invoking native compile, and I'm going to be saving, attaching as the artifacts of the output. So let me just trigger a release, and hopefully this will work. And while we trigger a release, I'm going to be show you something else. So I'm going to go here, draft a new release. I'm going to go 004. I'm going to say Micronaut MCP tools weather 004. And release name cannot be blank. There you go. Okay, so the native images are going to be generated here, right? So while this is running, I'm going to show you. So before we generated, we were invoking this thing with the MCP Inspector, and you probably are already bored of invoking these things with the MCP Inspector, right? So what we are going to do is I'm going to go here to Claude. And in Claude, this works also in GitHub Copilot, in C-Line, all of these programs, they have like the ability of register MCP servers. I'm going to be using Claude in this demo, but you go to settings, developer, edit config, and here I'm going to edit with Nova, for example. I'm going to do, let me just remove this. I'm going to do, command is going to be Java, and for arguments, we're going to be doing this. I'm going to call this disk space, right? So each of them, more or less, is the same idea. You define, sometimes you define the protocol, whether it's STDO, HTTP. If it's STDO, you have to define the command, and per command, you can supply arguments, right? So here I'm supplying -jar and my jar file. So now if I close Claude, restart Claude, okay, I don't know why it wants. So I have an error. Okay. Let me check if this is still. Why is complaining? So we should be able to see the logs in the. Seems an error with the Java version, something like that. Let me try this in. It seems it's picking the wrong Java version. Let me just try in Visual Studio Code. See, we have more luck. So I have it here. I'm gonna go in Visual Studio Code. You open the. I have it here open, but let me show you. So you do Command Shift P to open the command palette, MCP add server, and I'm gonna do Java. It says with optional Java -jar and the path to my jar file. I'm gonna say disk space. Let me just move this. Otherwise, there's gonna be a name collision. MCP Server, STDO. So hopefully this thing works. So now you probably don't see it, but here on the left corner, I'm gonna say, do I have any space left on my computer? You see the security that we discussed before? So it's asking me permission to run the MCP server, right? So it decided that one of the MCP servers exposes a tool that is a good fit. So I'm gonna say allow. It's basically telling me that I have around 133 gigs of free space available. And it's giving me some more verbose output, kind of LLM style. So as you see, pretty simple to, once you generated an MCP server with Java, these STDO servers, it's really simple to configure it in your favorite LLM. So here I configure it in Visual Studio Code, you can configure it in Claude Desktop, you can configure it in Copilot, in IntelliJ IDEA is really similar. Let's check if the generation of the native image finished. It's still running. While that thing is running, I'm gonna show you a quick demo of doing a MCP HTTP server with the Micronaut as well. So I'm gonna show you the weather that we are generating the native image. I'm gonna be showing you with HTTP transport. So I have another branch which I can actually update here. I'm gonna show you the code in a second. So in Micronaut, to define a HTTP transport, you use the same dependency. The only thing that you change is you set HTTP as transport here. And by default, Micronaut will expose an endpoint in /MCP. You can configure the path if you want, right? So if you want to call it potatoes, you can modify the path. And I'm gonna run now the app. As you see, it's telling me that it generated at compilation time the input schema for the alerts, and it started import 8080, and we are gonna try to connect with the MCP Inspector. I'm gonna go here instead of STDO, I'm gonna select a streamable HTTP, and I'm gonna do here HTTP localhost, and the port will be MCP. That's true why it says via proxy. Let me just close the inspector 1 second and open it again. HTTP localhost 8080. Okay. Okay, so I just connected to the Micronaut MCP server using HTTP transport. And as you see, I am exposing a tool. Actually, I'm exposing two tools. One is get weather alerts by location, and the other one is get alerts. And here the idea is that if you do like New York, this is gonna do a HTTP request to the weather API of the government. And there are no weather alerts in New York. Let's do Seattle, which always seems to have bad weather. I don't know which is Seattle is. I don't know what's the state of Seattle. Let's do California. No weather advisories. Let me see if... So as you see, pretty simple. Just to recap, in order to use HTTP transport, you just change the setting in application.properties and you are using HTTP transport. And the other thing that you have to do, which we removed is, which I have it here, is you need to have a server, right? So we have the netty HTTP server netty dependency here. I'm going to show you, while this finishes, we're going to take the weather API from an older release. So I'm going to take the native executables. I just want to show you the native executables. I have here the native executable for the weathers. Internet connection is struggling. So I'm downloading a native executable. As you see, the native executable is a bit heavier. It has 74 megabytes, but is extremely fast to start and consumes really few memory. So which is an extremely fast to start STDO MCP server is always something desirable. So I'm gonna go to my bin folder here, and I'm gonna copy this. Here, I'm going to execute it first because macOS is going to complain about security. So I'm going to execute it first. I'm going to first give it permission. So this is a GraalVM native executable. And this thing started without complaining, apparently, macOS security, which is surprising. So what I'm going to go now is let's edit this. Let's do, the command will be just to invoke this. Users. There you go. Now I'm going to stop Claude. Run it again. Fingers crossed. Demo gods are not with me now. I'm going to check security to see if this is kind of blocking the execution of the native executable. Apparently not. I think it's the internet connection, but okay. Nothing like. Okay, now Apple is complaining, so it wants to basically delete my MCP server. So let's go here in security and tell, please don't delete it and allow it. Don't, and here always allowed. So now we should be able to open anyway. It's really telling me be careful, be careful, be careful. So now we should be able to run this MCP server, which uses the stdio transport package as a GraalVM native image in Claude, if Claude starts. Oh my God. Just one more time, and if not, I jump to the next thing. Yeah, I'm on Ethernet, in theory. So in theory, I should be good. Just for fun, let me try to add it here. MCP server. So I'm gonna go here, weathers, alerts, and I'm gonna do command. Command. So I'm gonna try to run the MCP server instead of Claude because Claude is letting me down. I'm gonna try to run it in Visual Studio Code. Okay. And now, how do I get this? So I can say, are there any weather alerts in Seattle? It's calling the, it's not calling my tool, but instead it's calling the, it wants to fetch the website directly. Let me say skip. I'm gonna say, are there any weather alerts in Seattle? Use the MCP server weather alerts I just added. Let's see if okay, allow. So it started the native executable here. I don't know why it didn't start it before. Let's see. So I think it wants, I don't know what it wants to do. Never mind. Let's jump to the next one. I'm gonna show you. I want to show you prompts. So to show you prompts, I'm gonna show you an MCP server that I built for Micronaut called Micronaut Fun. And before showing you how to create prompts in an MCP server, I want to show you how can you use them. So I'm gonna use an agent. I'm gonna use Cloud Code. So I have here Cloud Code, and I have, if I do here a Cloud MCP list, I have one. Server in theory. So the servers in Cloud Code, it's basically goes here in so let me try to run it. So the idea here is you can create prompts that essentially tell the LLM what to do, right? So imagine you are working in a project. And you do here, once you have prompts, once your MCP server exposes prompts, you will see them here, right? So you see the autocompletes at the bottom. All these coming from Micronaut fan, they are basically my prompts. I will show you what they are in a second. So I can actually show you now. So imagine I create a class named book. Book.java. In microserialization, you have to whitelist the classes that are serializable, and you do by adding an annotation called @servable. Imagine you want to write a test for this. I want to write the test. I would like to tell basically my LLM this. Whenever I want to write a test, I will tell, please write a test to verify microserialization for this class, and I show you how to do this. So I'm telling you how to do this to the agent, right? So I don't want to be writing this over and over, and I want to share this prompt to my teammates. So I can come here and I can tell I can do MCP, I can do or Micronaut fan, I can select servable testing, and I can do book. And I am basically, it is exactly the same thing as if I basically wrote that prompt to the LLM, right? So Claude Code, if you have used it, is an agent that basically will perform changes in my project, and what it will do, hopefully, it will run a book test class with something. So it basically added a class. Let me see. It wrote a book test class, which I am not able to find. Should be somewhere here, I guess. Told me that they generated the class, but I don't find it. Book test. Where is the book test? It's lying to me, right? Let's try again. So now I basically wrote the class in the way my prompt wanted it to be written, right? So this is pretty useful in the sense that, so this is myself like kind of writing prompts for my work, but imagine you are like writing an MCP server for, I don't know, a completely different company that has insurance prompts that they need to write over and over again, right? So you can essentially create these prompts and pass them. I'm going to show you how this is written in Micronaut. I created a class in order to avoid having to even write a Java class. I created what I call class path prompts, which essentially is you can create a file in the class path. So this is just a markdown file, as you see. And you see the parameter here, class name, which will be interpolated. You can create basically a markdown file, and you can add configuration, which I will show you. So this is the prompt that I just wrote, is this one that I'm going to select. And essentially what Micronaut will do is it will register all the bins necessary for the prompt automatically without you having to do anything else. If you wanted to write the prompt, there is an add prompt annotation as well. So if you go to dos.micronaut.io and you go to MCP, the experience for creating the prompt is pretty much the same, right? So class path prompts, and then the other one is with annotation. So the same idea with annotation is you can create, you give the prompt a name, and you give the prompt the argument, and when the user fills the argument, it will be passed to the handler, right? Which will be the method execution. I'm going to run the app here. I'm going to actually not run it locally. I'm going to use the one that, because Micronaut fan is deployed, so we can connect to Micronaut fan and have fun. I'm going to go Micronaut.fan MCP. I think I have to stop the client again. and you're going to see the prompts in a second. So http. A dot. So if I go to prompt, so if you see the initialize, so the initialize phase is we have prompts, we have resources, and we have tools. I will show you all of them. If I go to prompts, you will see that I have all the prompts that I got auto completion. Not all the clients will work with prompts. So for example, Cloud Code works with prompt. Visual Studio Code also works with prompts. So if I come here and I do slash, you see these prompts here, they are coming from Micronaut Fun. They're the same thing, right? In Cloud Desktop, which is still thinking, let me try Cloud AI directly in the browser. If I go here and I go add from Micronaut Fun, the prompts are not listed. If I go to my mobile phone, the prompts are listed here. So there is up to the client whether they support it or not prompts. But I see prompts as being quite useful. Now let's talk about resources and resource completions, which I think is pretty interesting. In order to tell you that, let me show you what we have and let me give you some story behind it. So what I wanted to expose in resources is the specification defines two kinds of resources. You can have resources and you can have resource templates. Resource templates, they take arguments, similar to when we create a controller in Micronaut, in Spring, or with Quarkus, and we have a path variable. They can have parameters. I will show you in a second. So for example, we have quite nice tutorials, which I am quite proud of. In guides.Micronaut.io, we have like more than 100 tutorials. They are always built with the latest versions of Micronaut. They are quite automated, the generation, and they are written for the different combos that we support, Java, Groovy, Kotlin, Maven, or Gradle. And if you see the URL here, you see that this is what I call the slug, right? Then comes the build tool, and then comes the language, right? So how you could create like a resource that basically gets the HTML for that, right? So I have here a resource template which takes 3 parameters. So if I go here to the resource template list, let me just copy the output and show it to you. And I will show you how we do that in Java code in a second. So this is the response. Let me just do JSON here. So this is the response when the MCP client tell me which are your resource templates. This is the response that my server is answering, right? Typically, they tell you like to use kind of a URI structure, kind of the file, typical file structure. I guess this is because the origins of MCP being more used for Studio. And I have here 3 parameters, as you see, and in the other one I have 1, right? One thing that they define is they have also an API called completions in order to complete the template, and I will show you in a second. So if I go to resource templates, for the first one, how do you will do in Micronaut? You have a bin, a singleton, right? And then you have a method annotated with resource template, nothing fancy. It has 1 parameter, 1 path variable, and as you see, this is not a coincidence. This matches the method parameter, right? So when the resource template is invoked, this has to match, right? And then here we are returning a resource if we find actually the guide, right? So if the slug doesn't find any guide, we are basically throwing a resource not found exception, which is an error code defined in the model context protocol specification. So if I go to the MCP Inspector, and I here enter slug, if I do here Cognito, for those of you using AWS. So we have, for example, 2 guides using Amazon Cognito, which is an authorization server of Amazon, right? I have this one, which is for authorization code flow, and I think we have another one for client credentials, right? I have 2 guides. So how does the MCP client get these completions, right? So you can define a completion. there are two kinds of completion, one for prompts and one for resources. So for completions, for resource completions, you use the resource completion annotation, and the URI has to match the URI template of the resource that you are completing for. So this URI here is identical to the one I showed you before, right? So they have to match. You have resource template that uses the completions. You get the thing that the user is typing, right? And then you can return a completion, which is basically a list of strings. It has some more things. Basically, you can return up to 100 completions. And if there are more, you have to tell that there are more. And you have to tell the total. But essentially, it's a list of strings, basically. Nothing fancy. And if I select one guide and I click read resource, this will essentially invoke the resource handler here. So this is essentially getting this code. This is essentially returning the. We published a JSON document for all the guides where we have this metadata for the guide. So I am able to essentially return like the metadata of the guide, and I am returning as a JSON structure. I could even define a different output, right? The same for the guide HTML. For the guide HTML, this is more interesting, and I don't know if there is a bug in the MCP Inspector or it is a bug in the MCP Java SDK or in my code. I don't know. The idea here is how can you differentiate which parameter are you completing, right? And the idea is that the API you are going to be passed a completion request, and in the completion request you are going to get an argument, but you are going to get also the context. And what I am seeing is that in the context is always coming null here. The idea of the context, as far as I understand, is that if I enter here Cognito, right? For the build tools, we have some tutorials that are only available for a particular language, right? Or a particular build tool. And the idea here is that here, when I type, if the tutorial, for example, was only available from Maven or Gradle, I will change the completion, right? This is the way I think the API should work, but this currently I'm not seeing any completion. So the idea is that you are going to get these multiple calls to the completion endpoint where you have these resource templates with multiple parameters, right? So we have this regarding resource templates. Any doubts about resource templates? So resource templates are pretty cool in the sense that they allow you to get parameters and returns outputs depending. Let me show you another example of resource templates in an application where I have security installed. So I have this application, another pet project that I use to test things, which is this is an application, a Micronaut application secure with OAuth2, is using Auth0 as an external authentication provider. And if I log here, so I am using a custom domain, but this is not a Micronaut application. This is just Auth0. I mean, you probably saw the logo at the bottom. So I can log in. And this application exposes an MCP server for the user's games, right? The idea here is I have resource templates and I can get the PGN. For those of you who don't play chess, PGN stands for Portable Game Notation and is basically a text representation of a chess game. So I have here resource templates, and as you see here, same idea, resource template, you get the ID of the game. The ID of the game is my unique identifier in a database, nothing fancy. But the interesting thing is in Micronaut, you can use as a method parameter of tools, prompts, or resources, you can use the Micronaut MCP transport context, which is an extension of the MCP transport context, which is a class of the MCP Java SDK, which contains a method for getting the user locale, a method for getting the host, which is quite useful because sometimes you have to return the absolute link to a game. And more interestingly, it contains the principal, which is the authenticated user, right? So in this particular case, I am getting the principal. I am returning immediately if I don't have any principal. So if the user is not authenticated, I am returning immediately. I am fetching the games for the authenticated user. And if I find a game for the unique identifier of the user, then I am essentially returning that PGN. And yeah, this is pretty useful. This is basically using resource templates in combination with security contents. In terms of resources, here in Micronaut MCP, in Micronaut Fan, sorry, I could come here. I could say toggle web search. I'm going to say I have Micronaut Fan. My application is exposing as resources all the micro documentation. So I could come here and say, let me add the micro documentation for security. I don't think I click, or yes. And I'm going to add the configuration reference documentation. So if you are not familiar with micro documentation, all micro documentation follows a structure where we have a kind of a guide, and then we have configuration reference, which we generate at compilation time with all the settings that are available to you. So if I wanted to tell, if I wanted to ask the LLM something about Micronaut security, I can say, does Micronaut security support www authenticate, which is useful in MCP servers? And now we exceeded the message length for the chat, which is amazing. So apparently I got out of tokens in Claude. Let me try. We should be able to try this in a different. I don't know if I had in Copilot here. So let me try to open Copilot. So in Copilot, LLMs, MCP servers are a bit hidden. You have to select agent, click this tools button, and don't be in presentation mode, otherwise the screen doesn't work. Exit presentation mode. So you have to click this tool button here at the bottom. This icon right here, if you click it, you're going to see the tools that this one provides. And from MCP resources, you see all the resources that the MCP servers contribute. And I can add to the context of the call. I can add here the configuration reference, and I can say, does Micronaut security support www authenticate? And he's giving me a bullshit answer, basically. Okay? But this is the idea, that you can provide resources. Resources can be, I am showing you just HTML or text files, but they can be images, they can be PDFs, they can be audio files. So MCP specification supports many resources. Here I am basically exposing all the resources. To expose resources in a Micronaut HTTP application with MCP, you will do. You can register them programmatically, or you can use the add resource annotation. And in all these methods, if you return a string, we are assuming that you are going to return like kind of a text content resource, but you can always return like a read resource result and take complete control about the response. Okay. For prompts, you can also define completions as well, which you will define with the add prompt completion annotation. How can you test this thing, which is always important, right? So the official MCP Java SDK provides an MCP client, And the Launch4j library also provides an MCP client. What we have done in Micronaut is we have dependencies for each of those. So you have a dependency for the Micronaut MCP client Java SDK, and you have another one for the MCP. So it's basically these are bringing the other clients sensitively, and we are basically doing not a lot. We are basically doing it a couple of things so that your experience is nice. The idea here is you can define the URL that you want to point, or if you are using just to test your application, what we will do is when you start the Micronaut application, we will automatically point the MCP client to your server. What that means is that I can come here. Let me show you the test in Micronaut Fun. If I go here to Micronaut Tools, let me write a test. Let me just put in presentation mode so that is big enough. Again, I can come here. So what we want is we want to test with Inspector, but we want to have like unit test in our project, right? So the idea here is that I could come here and I could do test. Guides tool is available. Let me just put the phone in silent, sorry. I can add as a parameter the MCP client, which I have the dependency in my project already because I am a good citizen and I was testing already. So I have here the as a test implementation dependency, I have the Micronaut MCP client Java SDK. So I can inject my client here, and I can do client. I can do list tools. I can get the list of tools. This is already like classes in the. I can do a stream, any match, tool name equals, I think I call it guides. And let's verify this is true. Right? The test passed. So what we do under the hood is when you have the dependency, if you are running an embedded server, which is what we are doing when you are running the test, you are running the real server, what we do is we create a client pointed to that server so that you can automatically use it in your test. If you want to have clients that point to external servers, you can absolutely do that. You can have multiple clients pointing to multiple servers. So for example, if you wanted to create a kind of a hub of MCP tools. So now I can do here client, for example, a call tool. And I can do call, tool request. I can do name, guides. I think my guides tool doesn't have any parameter. Let me check. Guides doesn't have any parameter, so I can just invoke it like this. Let me just wrap it in assert does not throw, so that we gonna do assert not null. Guides. I'm gonna put a breakpoint here. Let's just run the test to see if it passed, and if it passed, we'll put a breakpoint. And I'm gonna show you something. Test passed. Let's put a breakpoint here. Have a lot of breakpoints. Forgotten. So if you see my console here, so what guides has, it has two things. It has structured content and it has content. And in content, it has text. So the idea here is, why do I have a structured content? I have a structured content because I am defining the JSON schema of the output of the tool. How do I do that? In Micronaut, we have done it pretty easily, which is if you are returning a class or a Java record and you annotate it with a JSON schema, at compilation time, I have generated this schema.json, which is a JSON schema. Let me just format it so that you see it. Format JSON. Hopefully it's big enough. So this is the JSON schema of my output, right? So this is pretty cool because you are telling the LLM, the MCP client, you are telling the MCP client, this is going to be the output of my response. And this allows for the client to make more intelligent decisions about how to use the output, how to parse the output, right? For compatibility reasons, there is this, when you are providing an output schema, the output schema will be rendered in structured content and it will be rendered also in text. It's exactly the same object rendered as a string and here rendered as an object. Make sense? Okay. Any questions about prompts or resources or anything like that?
When do you use like a tool for getting stuff, and when do you use a resource?
So a tool, a tool you can use essentially when you want to have the possibility that LLMs invokes the tool automatically. The resource typically will need manual intervention from the user. Even the specification is a bit vague and potentially it can. So typically a resource, as you saw here in my demo, I was manually adding the resource here, right? I was clicking here and I was manually adding the resource that I wanted to enhance the context. For the tool, you essentially, when you ask a question, it's up to the LLM to decide, to tell the client whether, which has already listed the list of tools, whether one of these tools will be useful to it. So what I did for Micronaut Fun is I did a little bit of both. So I created all of them as resources, and then I added like a tool to get all the guides and a tool to get all the Micronaut module documentation. And my hope is that LLMs will figure out when to use the tools and when to not. But this right now is a bit vague because you don't have any control whether they are going to call your tools or not, right? So because of that, it's really important that we define the input schema and the output schema really well with really precise instructions. One of the things that I have seen is, I will show you in a moment a couple of extra things, which is search and fetch. And the way I have defined it gets a little bit confused. So back to your question is, you will use a tool when you want to have the chance that the LLM calls automatically the tool for you, and a resource, the way I see it, is more manual from the user.
Can I plug? Yeah, this is a common question. In fact, with the ownership, the tools is owned by the LLM. Resources, prompts, you own your application and attachments on this with tools. So this is the diversification. So the tools, LLM decides when and what order to call them, and so that's why you cannot use the tool for everything else.
Exactly. So, more questions about resources and prompts. So I want to show you a couple of things. So ChatGPT, which is quite interesting. So I think my feeling, without following the industry a lot, is that ChatGPT was not really happy about MCP, and they didn't support it until really recently. And the support is a little bit limited. And if you go to ChatGPT MCP Server or something like that, let me see if I find the docs. So hopefully this is big enough. So they tell you can enable MCP servers by going to developer mode, which I will show you in a second. So here I am in ChatGPT. I go to settings. You go here to apps and connector, I believe. And you see I have Micronaut Fun already registered here. So you essentially have to toggle like development mode, and then you can add a custom connector, right? they define, if you scroll down the documentation, wait this. They define two special tools. One is called search and the other one is called fetch. So here is a user form, but basically they tell you that your MCP server needs to expose two tools. One is called search and the other one is called fetch. And they give you the output schema and the input schema, right? So what I did in Micronaut is, in Micronaut MCP, if you go here, you see search tool and fetch tool. I essentially created an API called fetch tool, and with a lot of imagination, another API called search tool. What if you basically create a singleton and implement that, it automatically exposes those tools to this as an MCP server tool. So if I go to my MCP Inspector here, I can show you, I have like a million tabs here open. So if I go here to tools, and I list the tools of Micronaut, you will see that I have a search tool, right? And a fetch tool, following the ChatGPT instruction for these tools. These tools are pretty much like a kind of a, so if you go to Micronaut, under the hood here, there is an open search. So if I go to www authenticate, that we were like trying to see before, this is like doing a search. And this is kind of what the tool allows, right? These tools automatically, they are registered as read-only tools, not write tools. And this is important because some clients, for example, ChatGPT, here you see the tools. These tools, they are basically listed. They don't have here, like if they were like write tools, they will have a warning here, like telling you that these tools are destructive. How do you tell that? So in Micronaut, search and fetch automatically are considered like read-only, right? Because they are search and fetch. And I can show you my implementation here. So this is my implementation of search tool for Micronaut. So I am implementing search tool. I have annotated that singleton. I am using constructor injection here to inject a search service. I am calling the search service, and I am doing like a stream API and mapping this to search result. Search result is a class basically that is in Micronaut MCP. And for fetch tool, pretty much same idea, right? The difference here is I am injecting the MCP context. I don't think for anything because I'm not doing anything with it, but the API forces you to implement it so that you have it available if you want to do anything with it. But basically, this is the API, really easy. If you want for your MCP server to work well with ChatGPT, my recommendation is that you include these tools. Micronaut makes it really easy, but if you are working with any other, with the Java SDK, pure Java SDK, with Quarkus, with Spring, this should be pretty simple to create as well. If you are creating other tools that are not destructive, you should use the annotations to tell the clients that your tools are not destructive. And you do that by using this annotation here, where you say this is read only true, destructive hint false, and you give the title as well. There are a couple of other options. One is whether the tool is idempotent or not, whether it's an open world hint. What that means is that it's is like searching in a closed set of data or more open, and the return direct, which I don't know if it's really used, is whether the output of the tool can be sent to the user directly, or you want the LLM to basically consume it and output something different. Make sense? So if your tools are not doing, if your tools are read-only, use tools annotation as read-only hints. This is also in Quarkus as well and in Spring as well. This is hidden in a place of the specification somewhere, which I probably will not be able to find now, but I think in schema reference, annotations here. Here, like tools annotations. So this is essentially what I was showing you using annotations. But essentially, I saw this especially in ChatGPT, where it was a bit scary when if you don't define this, you will see like a kind of a write tool here warning for the user. Let's talk about security, which is, I don't think we are as an industry there yet. So if I go to specification, security, authorization, let me show you the diagram and let's go together through it. So this is the diagram that I think we should aim for, which is our Java applications. They don't build an authorization server. We externalize an authorization server, right? So we use the Cognito, the Keycloak, the Spring authorization server, the Okta, the Auth0 as I am using. So you use an authorization server, and this MCP server, this is your Java application, right? So I was telling you before that this application, this chess game archive is secure, right? So my I'm going to open Rapid API, which is a program to send HTTP requests. And we're going to send a request to see what happens, right? So if I send a post request against chessgamesarchive.com model context protocol. I changed the path in this application for another story. I can tell you if you want. You get an unauthorized, and in the headers of the response, you get like an www authenticate header, which this value, which is telling basically, this is not a Micronaut specific thing. This is kind of an RFC specific thing that all our Java servers should basically do, right? So this is informing the person that is calling that, let me just paste it here in IntelliJ so that we can see it bigger. This is basically the response. This is essentially telling like, this is my resource metadata endpoint that you can consume, right? Because you are not authorized to access this endpoint. So back to the diagram, this is what I just did, right? So we sent a request, we are unauthorized, but in the www authenticate header response, we get where to go next, right? And we visit that resource. So let's do that in our application. So I'm going to visit this resource. And this resource, basically, there is another RFC, which defines the format of this thing, somewhere here. To sum it up, it basically tells where the authorization server is, right? And in the authorization server, so this OAuth chess games archive, this is no longer my Java application. This is an Auth0 server, right? And if you go to well-known OpenID configuration, let me just format it nice for you. This is another standard in OAuth. This is basically my authorization server telling the consumer the different endpoints and where they are, right? And the interesting part here is there is a registration endpoint. And this basically means that your authorization server supports dynamic client registration. So we will be right here. So you're gonna get, this is gonna get the authorization server, and here is gonna basically register an auth client. So if I go to my auth0 console here, okay. Bear with me. When you do the outflow, this is gonna register applications. And as you see here, this is getting out of control a little bit. So this is registering an application automatically. It's gonna authenticate the user. If the user agrees with the prompt, I will show you in a second, hopefully it works, demo. I'm gonna get a token. And what I am doing is I am validating in my Micronaut application, I am basically validating the token using the user info endpoint of the auth server. The MCP Inspector, which I should have in one of these tabs. The MCP Inspector supports this. So if I go to chess games archive.com, this could very well fail. To call. Connect. So this is the flow. It's basically, this is like now, like, because I am logged in the application, it's not asking me for the username and password again, but it's basically asking me for like the prompt, like this wants to access the profile, my email. I can say accept. And now I can access my server. So this, I am accessing my MCP server as an authenticated user, right? And I have a token, which you can see here, trimmed. And each request from the client is passing that token. My Micronaut application is getting that token, sending it to the auth0 user info endpoint. Is this token valid? Yes. I'm basically creating the authentication for the user. And you see here they have like a flow to essentially to verify this authentication. What I have found is this is a mess. For ChatGPT, for example, I tried to do this with ChatGPT because in ChatGPT, if you go here to developer, to data controls, what it is, apps and connector, create, you can select auth here, right? What I saw is that ChatGPT basically transport, sorry, I clicked the wrong one. What I found is that ChatGPT was not using the www authenticate, and it was basically trying to access this in my application directly. So it was basically acting as if my application was an authorization server. Okay, I said, this is not bad. I created an issue in the OpenAI developer documentation, and I got an answer like, yeah, it's fine. So I don't know. So I created in Micronaut security, I added this, which I consider a workaround. But there is a setting that, which is only in the latest version, which will be part of Micronaut 4.10.0. I added a way of configuring Micronaut security to proxy basically this request. So basically, you will proxy the request to authorization server to actual authorization server and getting the response back, right? So with this, you treat ChatGPT as if you were an authorization server. But then what I discovered is that ChatGPT, when doing the OAuth flow, it was not requesting the OpenID and the profile scopes. So the authentication was successful, but I had no idea what the user was because there were no principal. So I was not able to authenticate the user correctly with ChatGPT yet. I created an issue and several people seems to have had the same issue, and I guess this is like a work in progress. Another thing that I discovered in kind of horror stories with MCP and security is Claude was, which I think was good, they were saving kind of, okay, for this URL, they were caching the client ID, right? And I was doing my tests, I was happy. I came to Auth0 because this was kind of my Auth0 dev account, right? And I came here, chin, chin, chin. And I wanted to try from scratch. So I came and I deleted my applications, these Claude applications. And what I discovered is that Claude was always trying to connect to the client ID was deleted, never creating a new one. So the only workaround that I found is change the path. So that's why in the MCP Inspector, I was using here model context protocol instead of the default MCP, right? So be careful about deleting your dynamically registered client ID because some of these consumers will be caching those, right? So this is a work in progress in many things that I see. I don't think it's really a fault of the Java ecosystem. It's more so I think Quarkus, Micronaut, and Spring, what we have to do is we have to comply to the level-B authenticate, to the resource metadata. I think we will, all three frameworks will do it no problem. And then it's up to all the authorization servers to provide like a register endpoint, for example. I don't think Cognito does. I don't think Oracle Identity Domain does it yet. For Auth0, for example, what I discovered is that this only works if you have like a custom domain. So if you kind of create an Auth0 account and you want to try it out with the regular, not custom domain, it will not work. So pretty much a work in progress. In terms of what I think we need in the Java SDK, I think we need to be able to have APIs to be able to filter the tools by users, the prompts by users, and the resources by users. I am in communication with the Spring people, and I'm going to work on that. Because right now, the way I'm doing is I am basically, so right now, you cannot have an MCP server and say, for this authenticated user, I only expose the read-only tools. And for this other authenticated user, which has role admin, I export the read-only tools plus the write tools, right? So we need to go there. Okay. Any questions about security? No? So when you invoke a tool, right? In Micronaut, what I did is, and this can be done also probably in Spring and in Quarkus. I just don't know how to do it. You can inject the Micronaut MCP transport context, which if you are using security, if the user is authenticated, the principal will be populated, right? But for tools list, prompt list, and resources list, there is no handler, right? So you you don't have any control. It's basically everything is returned, right? So if you are doing things like I am doing, for example, in Micronaut Fun, I am exposing a lot of resources, right? In terms of, oh my God, Claude is letting me down today. So in here, right? Imagine you have in list resources, you want to list a lot of PDFs, right? And you want to list like, I don't know, like the annual sales PDF, but you don't want all the users to have access to that resource, right? So it is a problem. Right now, my only workaround that I see is you will only use resource templates, and then you will check the security constraint in the resource template invocation, right? But it's not great experience because if you want to, I don't know, it's easier to see like sales templates and click it than search for it with a resource template, right? More questions about security. Okay, so let me show you, just to wrap up, let me see if I had something else that I am forgetting. I want to show you a demo of, which I think is fun, not using any framework, but using the built-in HTTP server that Java has. So some of you may not have ever used it. I added actually a runtime that uses this. This is kind of, if you want to really go a few dependencies in Micronaut, you can use the built-in Java server as the runtime. Let me show you the example. So I actually created a PR where most of the code that I'm going to show you is, and I was talking to Christian before, and I think they're going to merge it. So I created a PR with a TCK so that we can run a TCK, the technology compatibility kit here in the Java SDK, but also downstream. So I am running the TCK also in Micronaut. And one of the things that I did is I wanted to run an MCP server with no framework. So I have here an example of these utils, which instead of using stdio uses HTTP transport, but it basically, how many of you have used the Java built-in HTTP server ever? Okay, so that's normal. So the Java HTTP server, let me show it to you. So I created this abstraction. So you use this API from Java, which is in the old package com.sun still, and you call http server.create, and you supply an init socket address, which you can supply like a random port. If you supply 0, there will be a random port. This starts automatically an HTTP server in that port. And then you can basically create context, which is kind of creating a handler for a specific endpoint, right? So a handler looks something like this. You receive an HTTP exchange object, which is the HTTP request and response representation of this API. So this is all Java internal API, no framework, nothing. Pure Java. This is built like forever. And here I am basically checking that it's a post request against an endpoint that is the endpoint that I define, which is /MCP. I am getting the body, right? And I am passing it to the transport, and then I am sending the response. And as you see, nothing that you cannot imagine what it is. This is returning an unprocessable entity, and this is the responding like a method not supported. right? So this is using the built-in HTTP server. So in my PR, I contributed this class, I contributed this abstraction that I would like to have downstream because I am using pretty much the same code in Micronaut. And in my PR, I changed the code so that the servlet implementation that is in the Java SDK uses this as well, so that we can have a single place and fix all the bugs here. And then in main, I can just do the same thing. Instead of using stdio transport, I can start the transport using this wrapper that I created. I have the tool for the disk space, and here I'm starting the server with the transport and just calling .start, and that start the Java server. And basically, I am outputting here the port that the server is running, which is always random. So this is started in this random port. Let me try Postman, which is another thing that has an MCP client. Let me see if this works. So I can in Postman, which is this program pretty useful to test REST API. They added like an MCP client as well. And as you see, this is connecting to my HTTP transport pure Java server running. And I can somehow invoke the tool. I don't know how to do this in Postman now. Not sure. Run, apparently runs the tool, makes sense. So you see here the MCP server using pure Java SDK. So as you see, pretty simple to build a MCP server with Java. You don't need a framework, but if you want to use any framework, use Micronaut, not use whatever you want. But as you see, the frameworks, they add a lot of layers so that it's less work for you. Most of the times you will be working with annotations, typically to define your tools, your resources, or those things. But sometimes you need to define resources programmatically. Check the Micronaut fan repository, which I think is a good example of an MCP server with all the three primitives. And I have a couple of extra demos, but I would prefer to have time for questions if there are any more questions. No more questions? Okay, let me show you then how to do the HTTP. So I haven't shown you HTTP with Micronaut. Let me show you HTTP with Spring. So as Christian was hinting me before, I'm using the Spring AI 1.10 milestone 3 version, and this I added a link in the repo documentation for this talk. I added a link to the version where basically they tell you about the protocol streamable property that you have to define in order to use streamable HTTP as a transport. So what's the difference between the application that we use for stdio and Spring? Here I have the Spring Server MVC dependency, and they have another one for web flags. And in application.properties, I no longer have to disable the console logs because this is no longer stdio, right? And as the protocol here I'm defining streamable, my tool and my application are exactly the same, right? So this is basically, I just change the dependency. For using streamable, you have to add this milestone dependency. You don't have to disable the server because you need a server, and you don't have to disable the console logging because this is completely fine. Let me show you now the example in Quarkus to wrap it up. Pretty similar idea. we don't need to no longer log into a file because we're no longer using HTTPO. We are going to use HTTP, streamable HTTP transport. In build.gradle.kts, we no longer depend on STDO, we depend on server-side dependency. Don't be tricked by the name. This is streamable HTTP as well. And the tools are exactly the same. Just a single tool. What else? What else? What else? There are a couple of things that I have not talked about. So I didn't show you the Langchain4j client. It's pretty much the same usage as I saw you with the MCP client. It's just a different API. But of course, as being clients, they are completely compatible with any MCP server, and all the servers that I showed you today, they are compatible. Postman supports MCP as well. Security, we talk a little bit. I didn't talk about notifications. So there are a couple of things that from a server you can do. There are solicitations, there are notifications, and the clients, they can advertise some capabilities. So they have sampling. The idea is that you ask an LLM to complete you. There is elicitation. This is, for example, where you want from the server to ask the client to ask the user, for example, to provide you the username. And there is logging as well. So these are some extra capabilities that typically you will use in a communication server to client, and you will use typically server-side events for this. And that's all I have. Thanks a lot, and let me know if you have any questions. Thank you.